This next section of our notes is on acceleration. So far we've been talking about objects that move consistently. Now we're going to discuss objects that either speed up or slow down. So let's start with the definition for acceleration. It's the rate at which an object's velocity changes. And I underline this word rate because we're going to see it come up throughout the year. Anytime you see the word rate, it's going to let you know that you should divide by time. Now we also want to make note that acceleration is a vector quantity. Hopefully by now you know that that means the direction is important. Since we know that acceleration is a vector quantity, when we write our equation, we're going to say A with the arrow on top of it to indicate that it's a vector equals, and then we'll use our definition to get the rest of the formula. Remember, the word rate indicates you should divide by time, so we do that first. And then, since acceleration is the rate at which an object's velocity changes, we're going to indicate that change with the delta symbol, that's your triangle, and then velocity is a V with an arrow on top of it. I also added this section for you. We can substitute in from our previous lesson that a change in velocity means that you subtract the final velocity minus the initial velocity. So overall, our acceleration is going to be final velocity minus initial velocity divided by time. Now let's look at the units. Velocity is measured in meters per second, and then since we are looking at a rate at which that happens, we are dividing by time, which is also in seconds. So I wrote you a little description down here. When we use the word per, as in meters per second, that lets us know how many meters in each second something travels. So when we have a meters per second, again, that's looking at the change in velocity in each second. And for our units, we don't really want to leave this as a double fraction, so what we would do is multiply the top and the bottom by the reciprocal. So our seconds down here are going to cancel, and that's going to leave us with meters over seconds times seconds, which is written as seconds squared. So the version of the units that you'll see in the word problems for acceleration is going to be meters per second squared. So let's think about these questions. Can an object have no acceleration and still be moving? So think about what that means. If an object does not accelerate, that means it's not speeding up and it's also not slowing down. So can an object still move but not accelerate? The answer to that is yes. An object can move with a constant velocity, so it's still moving, it's just not speeding up or slowing down, so we would say that it has no acceleration. It's very similar to having a cruise control on your car. You're still moving at the same velocity, you're just not speeding up or slowing down, so there's no acceleration. Now for the next question. When do you think an object might have a negative acceleration? We actually have two answers for this one. First, remember that acceleration is a vector quantity. So what that means is the direction is important. So if we have an object that's moving in the negative direction, sometimes we call that moving backwards, and the object is also speeding up, then that would be an indicator of a negative acceleration. So they're still accelerating, they're speeding up, but in that negative or backwards direction. Our other option would be to talk about the object moving in the positive direction. So let's discuss that. Remember that when we did the definition for acceleration or its equation, the change in velocity was what's important. So what if my initial velocity was actually larger than the final velocity? Let's look at this mathematically. If I start out with an initial velocity of, let's say, positive 20 meters per second, and a final velocity of a positive 10 meters per second. And let's just say that that took 2 seconds. When I go to put that into the equation and look at the change in velocity, when I subtract final minus initial for that change in the velocity, that's going to give me a positive 10 minus a positive 20. which is going to give me negative 10 meters per second. Once I divide that by the time, my acceleration would mathematically actually give me a negative number. So to summarize, our two cases when an object can have a negative acceleration, one is to be moving in the negative direction but speeding up, and the other case would be if the object is moving in the positive direction and slowing down. These two things make really good quiz or test questions, so make sure you go over them and that you understand. If you're not sure about anything on this slide, be sure and ask me about it in class. The last thing we're going to do for this section are two example problems. So let's go ahead and write down our givens. We have a car starting at 3 meters per second, and it's going to speed up, so that'll be our final speed of 24 meters per second, and that occurs in a time of 6 seconds. We want to find the acceleration. So go ahead and pause and try this one on your own, and then come back and check your answer. You should have gotten positive 3.5 as your final answer for the acceleration in this problem. I'll get you set up for the second example, and then you try to work it on your own. We know that the truck slows down from 20 meters per second, that's the initial speed, to 15 meters per second, which is the final speed, and this change occurs in 2 seconds. So now we're looking for the acceleration. Go ahead and set up the problem, pause the video, and then come back and check your answer. Hopefully when you did your calculations, you ended up with a final answer of negative 2.5 meters per second squared. That concludes our notes for this section, and I'll see you in class.